How much time do we have left?
80 minutes.
Aaron, where's your blue sheet? Come on, come on. Hurry, hurry. Krishna, we're checking the confidence interval. Here are the assumptions. Have a random sample of data from US biathletes. Why do we want randomization?
Because randomization reduces bias.
Right. When it comes to calculating the true slope of the population regression line, we wanted it to be as accurate as possible. This is why we want to reduce as much bias as we possibly can. The next assumption is, a linear model is appropriate since the scatter plot shows a linear pattern and the residual plot is randomly scattered. Why do we need this assumption?
I mean, it's a linear regression confidence interval, and so a linear model has to be appropriate if you want the slope of the data to be meaningful.
Right, and it has to be meaningful because we're literally doing an inference on it. Since the data points are evenly spread across the LSRL, sigma sub y is constant for all treadmill times. Why do we need this assumption?
The standard deviation in the vertical direction needs to be constant for all the x values so that the normal distribution is usable.
Yeah, we need the standard deviation to be constant. We can only have one value. Since the normal probability plot of the residuals is approximately linear, the Skit times are normally distributed. Why do we need this assumption?
Isn't it because the calculation for the critical value depends on the normal distribution?
Well, yeah, really it's a t-distribution because we have sample data, but yeah, basically. Now we're moving on to the calculations. Any questions? Yeah, the equation? So remember the confidence interval is the statistic plus or minus the critical value times the standard deviation. For linear regression, the statistic is the sample slope b. The critical value is d star. And Lillian, what do you think the standard deviation is?
S sub b, which is b over t.
Good. S sub b. Remember, we can put all this data in the calculator. Stats, test, linear regression, t-interval. Ollie, what's a confidence interval? Ollie!
Hi.
What's the confidence interval?
Negative 3.671 to negative 0.996.
Good. Now interpret the confidence interval.
We are 95% confident that the true slope of the population regression line of treadmill and ski times is between negative 3.671 and negative 0.996.
Minutes. You forgot the units.
No.
This table is so enthusiastic today. What's wrong with the rest of you? Ted Wu, wake up! I want y'all to work on the hypothesis test in your groups, and I'll be around to answer questions. Remember, the assumptions are the same as those of the confidence interval we just did. Remember, don't give your AP reader any reason to take away points. So practice like it's the actual AP exam. Yes, Umar without the K?
Umar without the K. Doesn't make sense. Umar doesn't even have a K in it.
Did you hear that right? I'm pretty sure she said Kumar without the K.
Ollie, what are you doing?
I don't want to do this.
Ollie, we literally don't have time for this.
Okay, Mr. Yi saw the exam scores on the statistics AP exam were poor and was shocked. Wondering what caused this disaster, he asked 10 of his students how much sleep they got the night before. He wants to persuade his class to get more sleep by showing a positive association between sleep and test grades in that particular class. Is there sufficient evidence that the true slope between sleep and AP statistics score is not zero? Assume that conditions for performing the test are met and that alpha is 0.1.
Assumptions. Have a random sample of...
Dude. It says assume the conditions for performing the test are met.
Oh, hypotheses then. Null hypothesis is beta equals 0. The alternative hypothesis is beta does not equal 0.
Remember to define the parameters. Beta is the true slope of the population regression line between sleep times and exam scores.
The test statistic is b minus 0 over s sub b.
Yo, why is it b minus 0?
It's B minus beta over S sub B. But beta is 0.
It's a model utility test. We want to see if there's a relationship between the two variables. So if the null hypothesis is beta equals 0 and the alternative hypothesis is beta does not equal 0, it's a model utility test. Your answer will be something like, there is sufficient evidence to suggest that the true slope of the population regression line between the two variables is 0.
Well, you can say there's sufficient evidence for the null hypothesis.
What do you mean?
Because the null hypothesis is that beta equals 0. The question asks if there's sufficient evidence that the true slope of the sample regression is not 0.
You mean population regression line?
Oops, the population regression line. But you can only have evidence that the slope is not 0, because that's what the alternative hypothesis asks.
Okay, so the alternative hypothesis is beta does not equal to 0. Makes sense. So for calculations, the degrees of freedom is n minus 1.
Degrees of freedom is n minus 2.
But for inference, what means it was n minus 1?
Just ask Miss Day, my dude.
Mrs. Day, come hither. Why is the degree of freedom not n minus 1?
Good question. The reason why the degree of freedom is n minus 2 instead of n minus 1 is because this is bivariate data. This means that you're subtracting 1 twice and not once. Understood?
Yep.
Okay, so the test statistic Z is...
Boy, it's a T distribution, not Z. You don't know the standard deviation of the population?
Okay, so T is 3.229.
The p-value is TCDF 3.229, 1E99, 7.
It's actually 2 times that since this is a two-tailed test.
Model utility tests are two-tailed tests.
So it's 0.0145, which is smaller than alpha, which is 0.05.
Wait, alpha is 0.1.
But it's always 0.05.
0.05 is the most common one, but on the question it specifically says alpha is 0.1.
Okay, so either way, the p-value is less than alpha, so we reject the null hypothesis. There's sufficient evidence to suggest that the true slope of the population regression line of sleep time before an exam and the exam score is not 0.
So there is evidence of a relationship between exam score and sleep time.
Miss Day, is there a PowerPoint of this on Google Classroom?
It's on my PISD.
Miss Day, shouldn't we do the blue matrix?
It looks like we don't have time now, but I'll do it first thing tomorrow.
Hey, is it just me or is this classroom a lot more fancier than usual?
You're probably dreaming.
Wait a minute.